Hi, this is Olajide from CTF Security, and welcome to the ninth day of Triacme Advent of Cyber 2023. Today, we're diving into the fundamentals of a .NET binary. We'll be exploring the dnSpy tool for decompiling malware samples written in a .NET framework. And lastly, we're going to build an essential methodology for analyzing malware source code. So without further ado, let's get started. All right, welcome back to day 9 of the Triacme Advent of Cyber 2023. And for today's task, we are going to be working on malware analysis. And we have a tagline that says, "She sells C-sharp shells by the seashores." And if you take a look at the right-hand corner of the screen, we have our Start Machine button. So I'm going to click on that. And it is going to take approximately 4 minutes to 3 minutes for our machine to finally load up. But while that is coming up, let's take a look at the storyline as usual. All right. Having retrieved the deleted version of the malware that allowed Tracy McGrady to control Fs remotely, Forensic McBlue and his team have started investigating to stop the mind control incident. They are now planning to take revenge by analyzing the C2 backend infrastructure based on the malware source code. So we are dealing with the case of a C2 server here. Now we have the following objective in this particular task. One, we want to learn about the foundations of analyzing malware samples safely. Secondly, the fundamentals of a .NET binary. And thirdly, we want to be able to use the dnSpy tool for decompiling malware samples written in .NET. And lastly, building an essential methodology for analyzing malware source code. And now we have some introductory lesson to malware handling here. And it is basically talking about using of sandbox because of how dangerous it is to handle malwares. Now we also talk about some features of sandbox, which include things such as network controls, visualizations, and monitoring and logging. So you can go through these on your own. So let's move ahead and see what else we have. Now we have another optional task here, which is the continuation of the task from the day 8. So if you wish, you can use the password here, which is the Advent of Cyber 2023 day 9 exclamation 1 exclamation to unlock the zip archive, which is the juicytomatoid.zip. But we're not going to be doing that. We're just going to be moving ahead with today's task. Now we have another important section here, and it says compared to other programming language like the C or the C++ language that use .NET, such as C#. Don't directly translate the code into machine code after compilation. Instead, they use an intermediate language like pseudocode and translate it into native machine code during runtime via common language runtime environments. This may be too overwhelming. In simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instruction, which is low level. Meanwhile, a C# binary, which is exactly what we are working on today's task, can be decompiled and the source code retrieved, since the intermediate language contains metadata that can be reconverted into its original source code. And that is basically what we are going to be demonstrating in this video. So let's just go ahead and start. But before we start going into our virtual machine, we also need to understand what a C2 is, which is the command and control. So the C2 or command and control refers to a centralized system or infrastructure that malicious actors use to remotely manage and control compiled device or system. It serves as a channel through which attackers issue command to compromise entities, enabling them to carry out various activities such as data theft, surveillance, or further malware propagation. And we have some diagram here to just illustrate that. So now moving into decompiling malware sample with dnSpy. So we're going to move to our machine I'm going to expand this so that we can take a look at the full screen. All right, cool. So what we need to do is to launch the dnSpy application. I'm going to right click on it and click on open. All right, so we have our dnSpy application. So I'm going to make this bigger, and then we'll go to the file menu. I'm going to click on open, and we're going to locate the location we have our sample file, which is in the artifact directory. So let's go ahead to the artifact directory here, and we're going to switch the file type into all files so that we can be able to locate our data. So we have our juicy tomatoid defunct data, and then we're going to select this data and we'll click on open, and this is going to load the information into the dnSpy application. Now, if you take a look at the application we have here, if you scroll down here and click on the arrow button here, we have our juicytomatoid.exe, which is the binary file. Now, if you click on it, we have our portable executable file information here, which is not exactly what we're working on in this video. So I'm going to scroll down to the program version of it. So when you click on the program here, you're going to have the list of all the main function within the program and other declared function as well. Now we have some couple of functions like the sleeper, the post-it, the main function, implant function, get it function, execute command function, encryptor function, decryptor function. So we're going to be taking a look at each of these functions to be able to understand how this malware code operates. So the first place I will need to go to is to the main function. So if you click on the main function, you might be wondering, okay, why do I need to go into the main function? This is because the main function is always the entry point into any application built with this .NET framework. So we're going to click on the main function, and then we'll see what we have contained in the main function. So let's scroll up a bit. Now, before we begin to analyze or read the main function, we need to take a look at other function as well. Then we can put all the pieces together and begin to understand how the main function of this application is behaving. Now let's move to other function. We're going to start with the post-it function. And on the post-it function here, we have the function declaration to be post-it, and we have two parameters being passed, which are the URL and the data. And then these parameters are being passed as a string. And next line here, we have creating of HTTP web request instance here. Then here we have converting the actual data, which is the parameter being passed here, into byte using ASCII encoding here. Then furthermore, we have setting up of the HTTP method to post. We also set the content type to application/x www form URL encode. Sorry about that. I think I mistakenly clicked on something. So let's go up a little bit. Let's close this. And then let's go to the post-it function. So we have setting of the content length, which is sent to the size of the byte variable, which is what we have here. We also have setting of user agent to Mozilla 5.0 Macintosh, which is meant to mimic the Mac operating system user agent. And on this line, we open up a stream to the request and write data to that particular stream using the request stream dot write here. And lastly, we are getting data from the server using the get response stream. So that is basically what the post-it function is trying to do. It is responsible for sending an HTTP post request to a specific URL with provided data. Now let's move to another function. So we're going to get it this time around. The get it function is very easy to understand. First of all, we are creating a get it function with a parameter called URL. Then we are creating an HTTP web request instance. Then we set up a user agent to Mozilla 5.0 Macintosh, which is exactly what was done on the post it function. Then lastly, we're going to send an HTTP request to a specific URL and return a web response using the get response stream also, just like in the case of the post it function. So basically what this function is trying to do is sending an HTTP get request to a specific URL and returning the response body here. And it's going to read the response up until the last byte using the read to end. Now we're going to move to another function. Let's go to sleeper function. Basically for the sleeper function, we have the declaration of the sleeper function with a parameter called count, which is an integer. Then we have the thread.sleep with a parameter count. What this basically do is it allows the program to pause or sleep for a specific amount of time. Now we're going to see much information about the sleeper function in the main function. So let's go ahead and pick up another function. So let's move to execute command function. So let's go ahead and try to read what we have on this function. So for the execute command function, it has a parameter with a variable called command, which is a string type. And then the first aspect here is we're trying to create a new process object. And secondly, we're setting up the process startup to configure execution environment here. And then we're setting up some information regarding the process. First of all, we want to set the process window style dot hidden. So basically what the process window style dot hidden is going to do is to make the command prompt hidden while executing the process we are creating. Secondly, we are setting the file name, which is going to run the command, which is the cmd.exe file on the Windows. Then we also have the argument with the /c, which is going to execute the command. Then we also have setting up of some of the start infos, like setting the use shell execute to false, setting the redirect standard output to true also. Then we're going to start the process, wait for the program to finish before it exits, and then we're going to return the output of the command from the standard output stream. Then if we move to another function called the implant. So basically what the implant is going to do is it's going to convert the base64 encoded string obtained from a specific URL here. And secondly, it's going to define a path where the downloaded file will be saved here, which is this line of code here. And it's going to append the name spykit.exe to the file, and mind you, it's going to locate the application data of the file. So if it is on Windows, we're going to be having something like the c/users/ possibly I beg your pardon, let me just check that. Let's say application URL, application data for Windows, or file path. Okay, so it's going to be possibly the c/user/your name, and it could be inside the app data directory. So let's move straight back to our analysis. After it has specified the file path, it's going to write the byte into that specific path. Then it's going to check if the file exists in that path. If it exists, it's going to display the path to the file or the name of the file on the screen. And if it does not exist, it's going to just return an empty string. Now, if we go to another function, which is the encrypt function. So first of all, on the encrypt function, we're going to declare the function, and it's going to pass a plain text as its parameters. Then we're going to define our encryption keys, which is here. You can see the encryption keys being defined, which is you can hack these super secure C2 keys. And then it's going to also declare an initialization variable, which is exactly what it is trying to do here. Then the program will also set some AES parameters. For example, it's going to set the mode, the padding, the block size, the key size. Then the program is going to use the memory stream to store encrypted data, which is exactly what we have here. Then it will further use the crypto stream for the encryption process. Then the stream writer is used to write plain text to the crypto stream. And then we're going to convert, beg your pardon, let me scroll down a little bit. We're going to convert the encrypted data to a byte array. And lastly, we're going to convert the encrypted byte array to a base 64 encoded string. So the decryptor function is also very similar, just that this particular part here is performing the decryption process and returning the result. Having understood all these other functions that have been declared within the program, let's try to make meaning to the main function. So for our main function here, we have our function declaration, and the first line here is getting a host name of the local machine here with the get host name method here. Then secondly, we want to define a base URL for command and control server, and it's going to be http McGrady secret 2.thm. So next, we want to construct a registration URL with the /reg, and we are going to append it to the str variable, which is what we have stored in this variable here. Then the next thing we're going to do is to prepare data for registration, including the host name here. So we're going to have data, and we're going to append the host name with the name equals to here, which is actually preparing the data for posting. So on the next line here, we're going to use the post-it function to perform registration with the C2 server and receive a unique identifier into the string 2. We're going to set our count to be 15,000, and we're going to set our Boolean flag to be false. So this section of the code here is carrying out an infinite loop, and within the loop, we're first of all going to be declaring, sorry about that. Let's quickly go back to the main function. So for the first part here, we're going to be running the sleeper function to sleep for a specific interval. In this case, it will be 15,000. Now, to be able to get the unit, if we go to the sleeper function here and you hover around the sleep here, you see that the integer is measured in milliseconds. Now, if you go back to the main function and you convert 15,000 to seconds, this is going to be dividing the value in milliseconds by 1,000, and we're going to get 15 seconds. So we have an interval of 15 seconds here. Then the next line of the code is going to construct a URL for task and result retrieval, which is actually the URL 2 and the URL 3. Then we're going to have the getIt function executed, which is going to get the task from the command and control server. Then we're going to have a check, which is going to check if a valid task is received. Then we're going to decrypt the task and split it into parts using the space string here, which is exactly what we are seeing here. The first element of the array is going to be extracted as the action, and any additional parameters are concatenated into the text variable, which is exactly what we are having on this line. Now for the action part, which is the first byte of the array, which is exactly what we have here, we have some actions which has been declared here, and this is exactly what made up the main function. Now we have a negation of a condition which says if, which is the negation sign, A is equals to sleeper, which is actually saying that if A is not equals to sleep, which is a function, which is a command or an action, then the second part says if A is not equals to shell, then if A is not equals to implant, and if A is equals to quit. Now, if we want to know what actual command will be executed whenever an action is being met, if we click on the if condition here, you are going to see the else condition. Let's scroll a little bit down. Okay, cool. So the first one, which is the sleep action, this is the command if a is equals to sleep. This is when a is not equals to sleep. So if a is equals to sleep, we're going to have the count equals to int pass as test, which is just going to adjust the time interval according to the parameters that we have here in the code. Now, if we go to the next one, which is the shell, and we click on the if condition, and it's going to execute this line of code, which is the program.encryptor program.execute command function. And this is what it is just going to do. It's going to declare a data tree, and it's going to pass the result, and then it's going to post it using the URL tree and the data tree as the parameters. Then we also have another function here, or another action, which is if a is not equals to implant. So the code that will be executed is the if condition that a is equals to quit, which is going to set the flag to be equals to true. So having seen what this main function is, in order to summarize what this function is actually doing, the function serves as an entry point for an application. It appears to implement a basic command and control, which is a C2 loops, where the program communicates with a remote server to receive command and execute them. And some of these commands are what we have here: the sleep, the shell, the implant, and the quit. Now, having understood that this program is actually communicating with a command and control server, let's begin to take a look at what we have on the question section. Now, for the first part here, the first question says, what HTTP user agent was used by the malware for its connection request to the C2 server? Now, if you go back, we're looking for a particular user agent that was used by the malware for its connection. So if you go back to our machine, and let's go to the post it or get it function, and we notice that a user agent was set here. The user agent is Mozilla 5.0 Macintosh Intel Mac OS 14_0. So we're going to copy the full user agent. Let me copy that again. Right click, we're going to copy, and I'm going to paste it in here. Submit. Okay, so that was correct. For the next question, it says, what is the HTTP method used to submit the command execution output? So if we go back to the program, and if we go to the post it, still on the same function, HTTP method that was used to submit the command execution is the post request, or the post method, I beg your pardon. So we're going to just go in here and put in post, and I'm going to submit. Then the next one says, what key is used by the malware to encrypt or decrypt the C2 data? So if we go back to our machine and we go to the encryptor, you see that we have a key which was declared here to be, you can't hack these super secure C2 keys. So I'm going to grab that key in here. We're going to copy, and I'm going to paste it in here and submit. So the next question says, what is the first HTTP URL used by the malware? So let's go to the main function. And if we go to the main function, we're going to locate the first HTTP URL. Is that the question? Yeah, the first HTTP URL. And the first HTTP URL is saved inside the string variable here, which is the McGrady secret2.thm. So let's quickly grab that. We're going to copy, and I'm going to paste it here and submit. Okay, I think that was wrong, or did I miss anything? First HTTP URL used by the malware. Let's check that again. Let's go to our machine here. Okay, so this is actually the domain, and then the /reg was appended to it on the next line. So let's just go back and add the /reg, and I'm going to submit, and that was correct. So how many seconds is the hard-coded value used by the sleep function? So if we go back to the sleep function here and we just hover around the sleep, you're going to see it in milliseconds timeout. So let's go back and we're going to just put here. Remember, before we actually assign the value here, if you go back on the main function, you notice that the count was declared to be 15,000. And if you go back to the sleeper function here, if you convert the count, which is 15,000 to seconds, this will actually give you 15. So we can just fix in the 15 here, which is 15,000 divided by 1,000. And I'm going to submit. What is the C2 command the attacker used to execute command via the cmd.exe? So this is actually simple to locate. If you go to the application here on the dnSpy, and let's go to the main function, and let's go to where the action for the command is located. So for the first action, which is the A is not equals to sleep, if we click on the if condition, we're going to see the command that is going to be executed. And before we pick the command, if you go back to the question, we're looking for what is the C2 command the attacker used to execute command. So let's go back. We're looking for execute command, which is this function here. And if you click on the else, you see that it indicates that this function belongs to this if statement. So if A is not equals to shell, then the else condition, which is saying that A is equals to shell, will be this part of the program. So the action here is the shell command. So we're just going to put in shell. We're going to submit. And then if you scroll down, what is the domain used by the malware to download another binary? So this can be found on the, I think, implant function. Is that correct? Yeah, so on the implant, if you go to the main function and let's scroll down to where we have our implant function. So we have the string text2 equals to program.implant. Then we have our URL as our parameter here. So the question now says, what is the domain? We're looking for domain, not the full part of the binary. So we're just going to grab the stash.mygreedy.thm. I'm going to copy, and then we're going to fix it in here and submit. Okay, do I miss something? Let's just add slash submit. Okay, what is the domain used by the malware to download another binary? Did I miss anything? What I'm going to do is to remove the HTTP and just go with the stash.mygreedy.thm. I'm going to copy and we're going to paste this and submit. All right, so that was correct. Check out the malware analysis module in the SOC level 2 part if you're enjoying analyzing malware. So we're going to click on completed. So guys, that will be all in this video. Please, if you've learned one or two things from this video, please make sure you like, subscribe and share, and I'll see you in the next video.